morning, everybody. I hope the day has started out well for you. So, of course, you already titled today's lesson, Lesson 8-2. And today's warm-up is designed for two purposes. It is designed to kind of quiz you on how you did on the previous concepts and also to review a couple of concepts from a while ago. So let's start with those. Numbers 1 and 2. Stay on your toes because the equity bars are in effect. Number 1, I've got student 13, 18, and 4. Student 13, what did you get?
I didn't get it.
Student number 18. Okay, student number 4. Okay, the correct answer is 3/2. Number 2, I've got student 2, 12, and 7. Student number 2, what did you get? Student number 12? Student number 7? 7/2. Number 3 does not lend itself very well to sharing out, so I will just reveal the graph. Move the screen up a little bit. This is what your graph should have looked like. Considering I gave you the domain, it should not have been very challenging to work your way through the graph. All right, I want to start with number 3, and then we're going to go to numbers 1 and 2 and spend a little bit more time. Does anyone, I have some students think about and share, why did I give you the domain -4, -2, 0, 2, and 4 instead of -2, -1, 0, 1, and 2? Anyone figure out why? Let's do it this way. I'm going to get to you and you, but here's what I would like you to do. I would like everyone to plug in a -1 into there, as if -1 was part of the domain. Let's pretend that -1 was part of the domain that I gave you. So everyone go ahead and do -1 right now. Give me a thumbs up when you've got the output. Good. Daniela, what is it? Yeah, it comes out to -1 3/4. So now someone, and I'm going to get to Isabella and Melinda first, explain why did I not put -1 in the domain? Why did I not include it, Isabella?
Because it doesn't come out to a whole number. Why does it come out to a whole number?
Okay, Melinda?
It would be hard to graph the fractions.
That was it. Take both of what they said and put it together. It's harder to graph fractions. And because the function has a fraction in it, a fractional coefficient, that fraction will create some fractional outputs, depending on what numbers you choose as inputs. So guess what? If the domain is really all real numbers, which it really is, the domain is all real numbers, but what I decided to do was give you a little bit of a clue as to how to best draw the graph. Also, the points came out up here and here for -4 and +4. Had I given you -1, we would have had a point here, we would have had a point here, and a point here, and then that's all you would have had, would have been these 5 points down here. It would have been a lot harder to draw a nice graph. What I would have seen was graphs that kind of went off like this. The tendency is to draw it very, very wide. So we get a much more accurate graph by including these here. So the more you can spread them out, the better off you are. Does anyone have any questions? So yesterday, or 2 days ago, I think, I said that we were going to use the same domain, but that was going to change. The domain we used was -2, -1, 0, 1, and 2. Those were the inputs we used. And that's very easy. But when you have a fraction, you need to pause and use your brain. You're not a robot. Don't say, Mr. Gallet said use -2, -1, 0, 1, and 2, so that's what I must do. That's not what's happening. What I'm saying is, for simplicity, that's what we have done. That's not what has to happen. You're not a robot. Use your brain. If there's a fraction, choose a number that will make the fraction disappear. Any questions about number 3? Good. So now let's go to numbers 1 and 2. I seem to have 0 success with numbers 1 and 2. This is an important idea that you need to know. I asked you to find me the x-intercepts. Clearly, 6 people in the room have no idea how to do it. Does anyone have any idea how to find an x-intercept? There's going to be a kick yourself moment. Go ahead, Milan, give it a shot. It's not a big deal. I don't want to, never mind. Why don't you just share with us?
I was gonna say y 0, but
Really? That's because that's exactly what you're supposed to do. Yeah, to find an x-intercept, you make the y a 0. To find a y-intercept, you make the x a 0. And then solve the equation. Find the x-intercept, make y 0. Give me a thumbs up if that's what you did. So clearly, good. So now everybody, you know the answer, but that doesn't mean anything. Now go do it with your colored pen. Solve the equation. 2-step equation. If you already did it, which as far as I can tell, there may be one person.
Well, redo it. Getting the wrong answer doesn't help.
So to be sure, this is what you're solving. That's fine, but we want to keep things how do you get from So yeah, I mean, you got the right answers. All right. So the first one, super ridiculously easy. Add 3 to both sides. We get 3 equals 2x. Divide both sides by 2. X equals 3 halves. Not a big deal. Should have had 100% of success. Moving forward, we will have 100% success. Number 2 is a little bit trickier. It's not tricky, but I tend to have more students who don't remember how to deal with this. But we're going to make sure you do remember. Just because it's a fraction doesn't change what you do. Add 7/3 to both sides. This cancels out. I'm going to continue over here. And we get 7/3 equals 2/3 x. Now, I need some students to remind us, how do we get rid of the 2/3? It's going to be another kick yourself moment. I know I'm going to hear, oh yeah. Melinda, it's coming back to you. Go ahead.
multiply by the reciprocal.
Yeah, multiply by the reciprocal. Multiply by 3 halves. Multiply by 3 halves. That cancels, that cancels that. And now multiply this. But you see that the top has a 3 and the bottom has a 3? Top 3, bottom 3 cancel. X equals 7 halves. Everybody in the room should be able to handle all of this, and to be honest with you, compared to some of the other things we've done, like factoring and multiplying powers, this should seem easy to you at this point. But there's a reason why we're doing this today of all days, because of this. This is the graph of number 1. So x equals 3/2. Right there. That is the x-intercept of the graph. In fact, anytime you have a graph cross the x-axis, that's called the x-intercept. So if I had a graph that went like this, these locations would also be called x-intercepts. Just because it's not a straight line doesn't matter. Even if I had a different type of graph, like that. Everywhere it crosses the x-axis would be an x-intercept. It's the location that makes the equation true when y is 0. Anyone have any questions about intercepts, x-intercepts? That is going to lead us into today. No questions? All right. So, today we're going to continue developing the idea of quadratic functions and their graphs and some other things about them. We just touched on one of the ideas that we're going to spend a bit of time on, which is the idea of an x-intercept. So, you will recall from a few minutes ago that an x-intercept is the value of x when y is 0. That's what Milan helped us remember, that you make the y 0, what will x be? This also has another name. It's called the zero of a function. It's called the zero of the function. The zero of a function is the same thing as an x-intercept. Two different terms for the same thing. You need to know both of them. A quadratic function could have 1, 2, or none. And I'm going to show you how that's possible. So, if a zero of a function is where the graph crosses the x-axis, well, we could have a parabola that goes like this and crosses in 2 spots, 1, 2. We could have a parabola for which the vertex is sitting on the x-axis. In that case, there's only one x-intercept. There's only one zero of the function. You could also have a parabola that never crosses the x-axis. In that case, there are no zeros of the function. That could also be true for all of these if they were upside down, opening downward. You could have a parabola like that. You could have a parabola that touched here, opening down, and you could have a parabola going through the x-axis. Okay? So you could have 1, 2, or none. Any questions about how that works? All right? So, finding zeros from a graph. You will see that I've given you the companion to the notes. So everyone find the graph on your little sheet that I gave you that matches this one. I'm pretty sure I handed it to you facing the right way, but it's possible it got flipped over. So, the question is, what are the zeros of the function? So what we're doing when we have a graph is we're trying to locate on the graph where is it crossing the x-axis and identify those numbers. So it should be pretty clear to you that it's crossing here and here. So what are those locations? We think that the zeros are at x equals what? Someone tell me. You can look on yours or look up here. Either way. I made it pretty big, so you should be able to see it either way. Where is it crossing, Ethan? -1. So that's, we think, a zero of the function. And what's the other location, Tatiana? 3. Very good. So that's the other location. Use a semicolon, don't use a comma, because then it's going to make it seem like it's an ordered pair, and it's not. So we think that those are the two locations, but we want to make sure that the graph isn't misleading. We want to make sure that maybe the graph is actually going a little bit outside of that number. Maybe it's a fraction. Well, we have the function right here. Here's the function. So there's a simple way to check. Anyone know how we check to see if we got the right ones? Mark?
You input the coordinates we got into the x.
Yeah. Take the two values that we found, plug them in, and see if they work. So we'll do y equals -1 squared minus 2 times -1 minus 3, and check and see if that comes out to 0. If it comes out to 0, that one's right. We will also do y equals 3 squared minus 2 times 3 minus 3, and see if that one works. If it comes out to 0, we got the right one. A lot of this can be done with mental math as long as you do things properly. And this can get a little difficult, so what I would encourage you to do is look at it like this. That's a -1 squared, that's a -2 times a -1, and that's a -3. Do some mental math. That's a +1, that's a +2. +1 and +2 is 3, plus -3 comes out to 0. So this one works. That works. Let's try out this one. That's a 9. It's a -6, and that's a -3. 9 and -6 is 3. 3 minus 3 is 0. That one works, which means these are the zeros of the function. Does anyone have any questions on how we did that and how we checked? Most of the time, I will not try to trick you. I will not try to put a point like somewhere like right there and ask you to figure it out. You're going to see that there's another way to do it. We're going to get to that a little bit later. But visually, if what you see looks like it's on the grid, these points are on the grid line, then they probably are exactly on the grid lines. So do your check quickly, do mentally, nice and quick. Any questions about that? All right, let's take a look at another. And it should be the second graph on the front side of that little sheet I gave you. And I gave you the sheet so you could write little notes on it, or little arrows or indicators. There should be a little bit of space on the side if you need to. So this is the graph of y equals x squared plus 8x plus 16. Find the zeros of the function. So where does it look like it's at? Deja? Yeah, it looks like it's at -4. But before I circle that and pat myself on the back, I'm going to do a quick check. And again, I can probably at this point do a lot of it mentally, but I'm just going to write it down so you guys can see. -4 squared plus 8 times -4 plus 16. Does that come out to 0? That's a 16, that's a 16, and that's a -32. It does. Comes out to 0. That is the 0 of the function. And you can see that there's only one because this parabola's vertex is the point on the x-axis. Any questions about finding zeros? Give me a thumbs up if you're understanding it so far. You're not an expert yet, but you haven't mastered it yet, but it's making sense. Good. Put your thumbs down. So now let's see how you fare with these two. These are not on the sheet I gave you. They are only up here. You do not have to copy anything, but you need to tell me the zeros of the function, and you need to make sure that they're correct. Okay? You got 2 minutes, and if you have time before the bell rings, check your answer with your teammates. All right. So let's see how we did so far. Part A, I've got student 14 and 18. Student number 14, what are the zeros of the function? Student number 18, what did you think? There are none. There are none. Very good. Part B, what are the zeros of the function? I got student 3 and student 15.
3.
Both think it's 3. And yeah, you can see it. It's right there. And when you test it out, it works. X equals 3. Very good. Anyone have any concerns or questions? Okay. So let's take it a step further and use these ideas to actually get us something. We actually get 2 things from this. And I don't want you to write anything yet. I want you to just follow along with me. One thing we spoke about a few times with when we were doing the table of values was how the top seemed to mirror the bottom. And that's actually makes perfect sense because a parabola is actually a mirror image of itself. The left side and the right side are mirror images of itself. If we look at any parabola we've seen, they are always mirror images. This is a mirror image of that. This is a mirror image of that. It has happened every single time. Look at all of the parabolas on the little sheet I gave you. They are all mirror images. The left and the right are mirror images. But a mirror image needs a mirror. It needs a mirror. And that mirror is called the axis of symmetry. And that you need to know. It cuts the parabola into two symmetrical halves, into two symmetrical pieces. The axis of symmetry always passes through the vertex. Always. The axis of symmetry is a straight line. You're an expert on straight lines. You can write equations of straight lines. They're called linear equations. So we can find the axis of symmetry a few different ways. If we have a function that has 1, 0, that means that the graph of it touches the x-axis at one point and that's it. Which means we already know where the vertex is. So all we have to do to get the axis of symmetry is draw a perfectly vertical straight line straight through that point. And that's what you see illustrated right here. That straight line has an equation. The equation of that line is x equals 3. You learned a long time ago that vertical lines, their equations are always x equals something, and horizontal lines are always y equals something. So this vertical line has the equation x equals 3. Any questions about that? Axis of symmetry? Okay, but what about here, where we can't necessarily tell exactly where the vertex is? We could see maybe where it is, but we don't have the point there. What could we do to find the vertex and then draw the axis of symmetry through it? Well, it's actually quite simple. If you find the average of the two zeros, that's going to be where the axis of symmetry is. Think of it as distance. See this point right here and this point right here? What's the distance between them? Going straight across. The distance is 1, 2, 3, 4. What would halfway be? What would halfway be? Go ahead as a chorus. 2. Halfway would be 2. So, in this case, we're going negative, so halfway would be negative 2. So this can be shown by just taking the average of the two zeros. Take the average means you add them, divide by 2, you get negative 2. And so the axis of symmetry will be x equals negative 2, and we can just draw a vertical line straight through it. Any questions about that? This was the real reason why I gave you that little extra notes companion, so that you could draw right on that rather than having to redraw the picture and then draw it out. So if you flip that sheet over, you're going to see the next couple of examples. So you should also have a ruler at your desk, as I had indicated earlier. So find the axis of symmetry of each parabola. Yes? It does not. Oh. That was an unfortunate mess up. Thank you for letting me know. Who needs... Sorry about that. Yours also? Anybody else? Sorry about that. Okay, so a little tiny detail. Axis of symmetry is drawn as a dotted dashed line. So I've taught you how to do that before. You just hold the ruler and then you put the pencil down and up and down and up and down and up. So when the parabola has 1, 0 and it's because it's touching the x-axis in one spot, it's very easy to find the axis of symmetry. So, the axis of symmetry in this case is just going to pass straight through there. But we also want to write what the equation of that line is. It's passing through -1. The equation of the axis of symmetry will be x equals -1. That's the equation of the line. That's the axis of symmetry. Does anyone have any questions about that? No questions? Okay, part B has 2 zeros. So here's where we need to find the average, and you're going to see why doing the average is actually a great approach. This 0 is 1. This 0 is 4. If we find the average of that, what do we get? Simple mental math. Natalie? 2.5. Very good. So now we know that the axis of symmetry is going to pass through 2.5. So we already know the equation of the line. The equation of the line will be x equals 2.5. And we can draw it by just trying to approximate where 2.5 will be and drawing a vertical line through it. And so we have the axis of symmetry, and we have the equation of the axis of symmetry. Any questions about finding an axis of symmetry? Okay. Now, I made a mistake, I realize now. I didn't think about it until just now. That I did not include this checkpoint on that sheet I gave you. I do not want you to sit and draw these out. So rather than have you draw the axis of symmetry, what I would like you to do is, based on the pictures that you see here, write me the equation of the axis of symmetry. Okay? Does that make sense? So I should have given you the graphs. I apologize for not doing that. So find me the equation of the axis of symmetry for these two. That's about 2 minutes. And if you have time, I would like you to compare your answers with your teammates. All right. So let's see how he did. Again, just looking for the equation of the axis of symmetry for part A. I've got student 19 and 9. Student 19, what'd you put? And student number 9 is not here. And that is correct. It would be x equals -3. Very good. And part B, what is the equation of the axis of symmetry? Student 14 and student 21. Student number 21. And that is correct. It would be at x equals 1. Any questions on finding the axis of symmetry? So far, fairly basic stuff. A lot of it visual. Hopefully you feel confident. So now we take it one step further and take away the visuals. So, what if you have a function that doesn't have zeros, or you don't have a picture? Well, there's another way to find the axis of symmetry. There's a formula. And you are going to have to know the formula. It is quite simple. But when you have an equation, a quadratic function in standard form, you can find the axis of symmetry by using that. X equals the opposite of b over 2a. So here's how it works. This is a, this is b, this is c. You already knew that. So you identify a, b, and c, plug them in, simplify, and you get the axis of symmetry. B is 4, a is 2, plug them in. You get 4 over 4, but it's always the opposite of the result of that. So 4 over 4 is 1, but it's going to be -1. So the axis of symmetry is -1. X equals -1. You can actually use this for something else as well that we're going to do in addition. But let's focus on this first. Any questions on the formula? So you are going to have to commit this to memory, but here's the thing. You should do it so many times that it just kind of naturally becomes part of who you are. It's not something you should kind of sit with note cards and go, okay, the formula for the axis of symmetry is x equals the opposite of b over 2a. Okay? So let's go ahead and work on this ourselves. Find the axis of symmetry of the graph, but we don't have the graph. The function is y equals -3x squared plus 10x plus 9. The formula is x equals the opposite of b over 2a. For my advanced students, only my advanced students, you can just take this and apply it to the top and just say the opposite of b over 2a. If you really wanted to, you can move that to the bottom. But remember, it's not both. It's either the top or the bottom. I tend to think of this as -b over 2a. But it's up to you to decide what works best for you. So, this is A, this is B, this is C. X equals the opposite of B over 2 times A. Simplify. X equals -10 over -6. Negative over negative is a positive. We get x equals 5/3. Since this represents a coordinate, also, if you wanted to, You could change this to 1 2/3. You could put, no, I don't want to put parentheses. You could change it to 1 2/3 as well. That would be appropriate, or leave it as 5/3. Does anyone have any questions on how we found the axis of symmetry? Now, I want to go back to 1. I want you to notice that, see here on this one, we found the axis of symmetry was at x equals 2.5. But we do not know where the vertex is. It's somewhere here, but we don't know exactly where it is. Well, we can actually use this to find its exact location, and that's what we're going to do now. Find the vertex. It doesn't say the axis of symmetry, it says find the vertex. So here's what we're going to do. We're going to do the exact same thing we just did. We are going to use the formula x equals the opposite of b over 2a. We're going to find the axis of symmetry, and from that, we're going to find the vertex. This is a, this is b, this is c. X equals the opposite of b over 2a. What does it come out to when you simplify it all the way? Just a couple people were able to do that. Ethan, what does it come out to? Yeah, it's -4. X equals -4. So the axis of symmetry will be a vertical line going straight through x equals -4. But we just found the x coordinate of the vertex also. We're asked to find the vertex. We now know that it's going to be -4, comma, something. How do we find the y? This is something you've been doing since the first week of school. How do you find the y? Maybe. Yeah, plug in the -4 into the function, and you will get the y. It says y equals all of this. Plug in the -4. So, finding the vertex just has one extra step beyond finding the axis of symmetry. So we will do y equals 0.25 times -4 squared plus 2 times -4 plus 3. Simplify that, and you've got your y coordinate. Let's see, here's my mental math. -4 squared is 16, and that's really 1/4 of 16. I can do that mentally. 1/4 of 16 is 4. So I've got 4 and 3 is 7. And I've got 2 times -4 is -8. So I've got -8 and +7. I now know that y is -1. And so the vertex is going to be at 4, comma, -1. All of this is based on this formula. Right here, x is the opposite of b over 2a. Any questions about what we did here? Any concerns of any kind? All right. Checkpoint number 3. Part A, find the vertex of the graph of that quadratic function. And part B, find the axis of symmetry of the graph of that function. So, a little bit more involved, so we'll put 4 minutes on the clock. If you finish before the time goes off, compare your answers with your teammates to see how you did. All right. Well, I hope you had a chance to compare your answers with your teammates. Let's see how we did. Part A, what did you get? I got student 5 and student 21 and student 12. Student number 5, what'd you get?
-1, 4.
Student number 21.
1,
So we have a disagreement already. Student number 12. So we have a big disagreement. Correct answer is 1, -4. Part B, find the axis of symmetry. I've got students 16, 15, and 3. Student 16, what'd you get? Student 15. Student 3. X equals -1/4. Make sure you put x equals because it's an equation of a line. It's not really representing a value per se. It's an equation of a line. So we seem to have some hiccups in part A. Give me a thumbs up if you got part A correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, put your thumbs down. So my students who did not get part A, could you go back and try and find where you went wrong and give your paper to a teammate if you can't find where you went wrong and see if they can find where you went wrong. Remember, this is a safe place to make mistakes. Nothing bad can happen. If you can't figure it out, then I will help you. Yes?
Yeah, I actually like finding the excess of taxes and for me, I actually.
Ah, so you just flip-flop the goal. Okay, I can deal with that. I couldn't hear you, I'm sorry.
I got it right, I'm just in the wrong part.
Oh, okay, good. So those are simple things that we can fix in the future. Anybody else? Good. Draw a line across the paper. Your homework is lesson 8-2, practice B, numbers 1 through 12. And you are doing Algebra Nation section 2, should get started.
When I went on, I got bogged
What?
on.
Hold on, we'll get to that in a moment. And your chapter 7 test I told you was when? Tuesday.